you for answering the questions. I mean, this is as many of you as answered. So the good things here is everyone knows Grasshopper to some extent, so we don't have anyone who has no experience with Grasshopper. I'm not going to cover like, just a component kind of thing. I made sample files, so there are not that many components that we drop, and then we'll see how the workshop goes. Depending on how it goes, I might share the file with you so you can just click, or we just build it together. Then the good thing is most of you have an understanding of radiance and honeybee energy. Again, this is not a workshop talking about like that simulation itself. I'll cover recipes, but hopefully you understand the overall workflow. And then many of you haven't tried Design Explorer, Colibri, or Fly. So this will be the part that actually, like in this workshop, I'll cover and you learn about our new Fly component and how to set up, because you don't, for the ones who have already used them, I think you will see a lot of improvements. For the one who haven't used them in previously, so this will be a new thing, but it's good. It comes from years of doing things wrong. So this is now makes more sense. Most of you have fewer than 100 iterations, which is basically one, it looks like, for one large building. And then we have one person who has more than thousands of iterations. So break it down into smaller pieces. Don't try to run 1,000 together. Let's talk together. Why do you need 1,000 iterations? And then somewhere between 100 to 240 or 240 to 1,000 is usually reasonable and very doable right now with pollination. So this was, what are you interested to run? We are not going to cover CFD or overall envelope or structural optimization, but these are running all the ones that we have on the top 5 are possible. Daylight study is like the one that most people wanted to run, and I will show a sample of daylight study, but I will use a simple box to show like the logic for setting up parametric studies first before getting there. So by the end of this workshop, you will be able to understand the overall workflow of setting up parametric studies, like what are the things that you should keep in mind, what's the input, outputs, what are the, things that usually you do wrong. And a lot of that is for running stuff on Pollination Cloud, which will be useful even if you run a single large model. And then understand the most common misconceptions about cloud computing. I think that's very important too. When you want to start running cloud computing, there is a major gap here between like what's possible and what people want to do or think it's possible, or what it takes to do what you want to do. I hope I can cover that. And I'm hoping that you get a better sense about the right strategy for submitting large parametric study based on like how many models do you have, how big is your model, and how do you want to run the study. So we will not cover code compliance recipe. This is not a workshop about that. We have some recipes for code compliance. We will not cover a structural optimization, but you can run it locally with any Grasshopper plugin that does a structure if you understand the logic. And we're not going to cover the modeling in Rhino plugin in this workshop. This is only about the Grasshopper side. However, I'll mention like how Rhino can simplify this whole process. Between give a man a fish and teach a man to fish, this workshop is here, right? So what I'm interested in is not like everyone to run a study with like 200 simulations. What I'm mostly interested is for everyone to understand how to set it up if they want to run a simulation with 200,000 simulations after this workshop, or with a large model. As a result of that, I've designed the workshop in a way that I want you to make mistakes, right? I want the things that can go wrong. That's part of it, and then we'll fix it as we go. So there will be things that I'm not going to tell you the first time, so we just do it wrong, and that's totally fine. You can point out those things if you want, and that's also totally fine. So let's get started. Let's make sure everyone has things installed and they will have no issues with following. So if you open Rhino and Grasshopper, I'll give you, and the other thing is I don't see your screens. So if you need me to slow down, or if you need me to wait, you can just raise your hand virtual way, or send a message so I can see that. So I need everyone to open Rhino and Grasshopper and make sure they have pollination installed. And then they see these three fly and fly ID. And they also see these two pollination components. Depending on your settings, you might see it like this, right? Pollination, but you should see the tab. Everyone is okay. Anyone needs some time. If you installed the single click installer, you should be good with that. So that's the first thing. The second thing is if you open like a new document, go to under the pollination and then check this component setup runs, or you can double click and get it, right? Setup runs. So this component should tell you like to log in, unlike mine. So let me sign out. So if you double click on the component, this will show up and it will let you log in. So I suspect some of you, if you have never used it, you might get IT issues here. I want to know who these people are and like you try to fix that. So go ahead and try to log in the way that you logged in or created your account already. So I'm going to log in here. And once you log in successfully, you will see this. And you should see your name here.
I I kind of got that. I kind of didn't. I just want to make sure I'm doing this right. I have
Okay.
like a pollinate tab and then I have to set up runs. Under pollinate, it says like hi and then my username with a smiley face. But then under
Okay.
setup runs, it says log in first.
I think that's because that was like just do Control E, like disable,
Okay,
it will show up. Yeah, I think that's because the state of the component hasn't been updated,
got it.
right?
Cool.
Yep. Everyone else? And if you can turn on your camera, please do, because that gives me a better feeling of like who's alive. I mean, if you need to take a nap or something, that's okay. You don't have to. But if you can, that's helpful to see your faces. Um, yeah, and see how it goes. Okay. So as I say, this is not realistic. Someone should have some issues. If you have some issues, but it's okay, you don't want to follow, that's also fine. But like the fact that everyone gets it right is a bit of a too ideal to be true or too good to be true. Any case, looks like everyone has it. So I believe you. Then, so if everyone has it, everyone were able to log in, you still have time. The first example that I'm going to cover has nothing to do with pollination. Logging into Pollination Cloud, as long as you have the components, it should work. So this is the first example that we are going to work with is slideshow is just a box. I have three inputs. I have three outputs, and I'm going to show you how to translate this uh, definition for a parametric study. So what we want to do, we want to run a study that goes through all the combination of these inputs and then generates all the outputs. We will collect all of those and we will visualize it on Design Explorer. If you haven't worked with Design Explorer, I saw some of you haven't, that's how it looks like. It's here. It's kind of now fairly old project that is developed at Thornton Tomasetti. And yeah, it's a very powerful tool for basically running and visualizing parametric studies and filtering through them and understanding, the results. So what we are hoping to do is to generate something like this, but prettier, kind of like getting the relationship to see how all the boxes can be generated and what's the relationship between volume and surface area. Sounds good to everyone? Okay. So the sample file is, I already uploaded the sample file here, so we can download it from the Google Drive. It's there's only one file there for now. It's called 00cube example. And I'm going to open two. I think I already had it open.
So do you need to run that user data component every time you open a new script, or just run it once in Grasshopper when you first open it?
Which one?
The one that prompts you to log in to the cloud?
So that should only show up once when
I see.
you log in, then you don't have to. Like you're now
Okay.
logged in, it knows where you are. And checking is easy. Like just bring one of these components and see like,
Right.
right? Okay. So let me break down this very advanced script that we have. And yes, I didn't make the curvy tower that people built. I think anyone who does that should be like, I don't know, your license should expire for like 3 weeks. So you can't use Grasshopper for 3 weeks. So don't do that. The revolving tower, and there is a building in Canada, actually, someone built it. He didn't realize that's just a sample Grasshopper thing. So what this thing does is a very simple, right? On the left, you have three sliders. One is like for X, the other one is for Y. And when you change this should change, but in my case, it doesn't. Let's see what's going on. Okay, this is new. Is it connected? Do you have the same issue? Oh, okay. It's what was happening, I don't know. So, huh, interesting. When I do this custom preview doesn't get updated. Do you have the same issue? Or is it
Yeah.
only me? How did
Same
I do
here,
that?
yeah.
How in the world did I do that?
It seems like all of the outputs are not necessarily associated with the sliders.
Right, so let's do this. So if I do Control Q on this one, or is it Control E? Control E. This is a complicated Grasshopper script.
What are your
What's going
units,
on?
Mostapha? What are your Rhino model units?
Is meters.
There's only one
Uh,
input in the arrow list, right? The first slider. So
Yeah.
the one that's affecting the cube.
What is that?
The first slider is the only one that actually affects the cube dimensions. That's the only thing in the list.
This
That guy.
one?
Yeah, that's the only, I guess, parameter.
But
Because it's a list of one.
such an idiot. I put that. Okay, very nice. Well done by me. Uh, how did I do this? Sorry, everyone. So this is how it was supposed to be. Yeah, I know what happened. I decided to simplify this, and I made it more complicated. So okay, now it should work. Wow, that's embarrassing, but good. So thank you so much. So this is just a simple box that you can see, even you can mess up this. Well done by me. So it has XYZ, right? Just changes the size of the box. Everyone can update their thing, so you had to delete that component that I put in the middle and then just connect the sliders directly to the box. So for Z, so what I did, these ones are sliders, so it goes one by one. For Z, I put a panel here. The difference is this is where you can't use a slider, like you have a bunch of values that you want to put in and they're not necessarily linear. You have a box here.
Mostapha, by the way, your slider is not set up correctly with the indices. It's going from 1 to 3 when it should be from
0
0 to 2.
to 2.
Yeah.
Yeah. So I mean,
Or
again, how
you
many
have to change
sections
the
make?
range.
So this is 0 to 2, but I think 1 to 3 still should give you, it will be confusing, but the same result because this component basically goes backwards.
Oh, right,
Like
because
here.
it wraps. Okay.
Right.
Yeah, you're
Yeah,
right.
but I mean, that's correct. So I changed this slider also to be to 0 to 1. I mean, this was not by design. The one that I said, like, I'm going to help you make mistakes. But this is not what I wanted to happen. We haven't started making mistakes, but and this is where we are. But this is basically 3 sliders, making the change. I'm calculating the volume here, calculating the area here, dividing the two value to get the ratio between V to A, right? Volume to area. So what I want to do is I want to run this logic, and this logic can be anything, right? It can be a daylight simulation, energy, structure. I want to see how all the combinations between all these input sliders is going to affect the outputs. To do that, what we need to do, we need to animate the sliders one by one, and we need to collect the results all the way in the back. And the component that does this is called Fly. And don't confuse the Fly from the Ladybug legacy with the new flies that comes with pollination. So the new ones, there are 2 components here. One is Fly ID, and the other one is Fly itself. Makes sense? Just go ahead and drop them on your screen. So what Flight ID does is basically this is the component that collects all the inputs. So every input that you have in your parametric studies should be connected to this Fly component, Fly ID component. And this Fly ID collects all of them and creates a Fly ID for you. So what I'm going to do, I'm going to start connecting them one by one. For sliders, you just connect them directly. And you can see when you connect, it just changes the name based on the name of the slider. So if you had a slider that didn't have a name, like this one, if I connect it, then the name, this one, because it had an X, it stays as X. But if I connect it to this second one, it gives me an error because I'm connecting to 2. But now you can see the name doesn't really change. So what you really want to do for your sliders, you want to right click here and name them correctly for what you want. This is important because this name is what will show up in that Design Explorer chart. Make sense? So that's why you have to take the time and basically create the correct name for your slider. And then the other thing is, as you can see, this is one of those components that you can zoom in and out. And when you zoom in and out, it basically allows you to add more or remove the inputs, but it should work automatically. So if I connect the first one here, this will be X, and it will give me another one. This will be Y, right? Another one. For Z, the slider is not what I want, right? What I really want is this list of values. So what you can do, you can connect this list directly here. And Fly component knows this is a panel, and it will iterate through all the values that you have in the panel. Make sense so far? So now if I check here, there are 2 outputs. One is the ID. The other one is the values that comes out of the component. So the ID is basically the name, and then value, name, value, name, value. Makes sense? Oh, one thing. My document is in meters, and for this one doesn't matter much, but for the next one, when we run daylight, we want to make sure everyone has their units in meters, so the size of the room makes sense. You're okay so far? Easy stuff. Okay, so let's go ahead and run this and see what happens. I mean, this is not set correctly yet. So the way to run this, you take Fly ID and connect the ID to this Fly component, right? So this one collects all the information, then it passes all the information to this component. And then here, now if you say Fly, it knows that 3 input has been connected. And if you say yes, it will start going through all of them. Were you able to do that, everyone? Without any problems? So technically the workshop is done. This is all you need to do. Just connect sliders goes and you're happy, right? But there is more here. One is if we check the results here, actually, you will see that all the ones that are collected by this thing are correct. 1, 1.3, 3.2, and all the way going to 4.2, right? But if you check the value here that's connected to the script is 3.6, right? Because when I did this, connected this, I forgot to remap the values. So instead of having it like that, when you use the fly component, you have to remap the values. So for this case, these two are sliders and it's fine to be connected. But my suggestion is to just clean up everything and use this values output to feed everything to your script. So the way it works is now I can delete this and I can delete this. And now you will see why the script that I gave you guys what was set wrong. So what now I need to do, I need the list item component. And I'm going to connect my values to list item. And what I'm going to do, I'm going to zoom in and add plus here to get as many inputs as I have in the outputs, right? So this will be X, this will be Y, and this, the third one will be Z. So now I can do this, this, and this.
Hey, before you plug before you plug the list item into the center box, Fly was able to understand that the center box is the thing that's being iterated, even though it wasn't connected to the box at all.
No, Fly is so dumb, and that's a good thing. Fly doesn't know what it does. What it does is basically it goes backwards, and it says, oh, there are things connected here.
Right.
Let me just change the values with them. The reason the center box was changing was because the sliders were connected directly. And what Fly was doing was going backward and say, hey, change the value from 5 to 4. And when it wasn't changing the value, this would change.
Oh, I see.
Does it make sense? That's a
Yeah.
good thing. Like Fly has no idea what you're doing. And that's the power of it. So you can connect anything to it. It doesn't need to know. You don't need to tell like this number is like window to our ratio or is a depth or something. It has no idea. It just says, oh, it's a slider. Let's me move it one at a time.
Yeah.
Make sense? Good question. So yeah, so this is how it looks like, right? So the things that you might have not known, I don't know if you knew like the list item does this, like you can press plus and add more items. So that's one thing to keep in mind. But this is something that I really like about this workflow, right? There is this line here that you can draw, and hopefully you can draw it better than I did, that basically separates all these inputs. Everything goes through Fly. So everything that you want to change should go through Fly. And then you will have your logic here that should be, whatever it needs to be. And that's very important because if you learn this workshop, then you can go learn the logic in this workshop or the idea, then you can just change that logic to whatever you want. And it doesn't matter, and the workflow should work. So that's the key here, to make it as generic as possible. Okay, now that we connected all this three, let's go ahead and do another Fly and see if everything works. It tells you 3 inputs are connected. This is 75 iterations. Do you want to run them? And you say yes, and it will run. And this time you saw like everything is connected and everything works as expected. Any questions so far? No? Okay. So now that we have this, and hopefully it makes sense. So the first step is done. We have the inputs, and you can see every time that I run Fly, it basically records all the things that happens. Here, it says there are 3 inputs. The first input called X, the second one is called Y, and the third one called Z. And these are the values that were passed in for those inputs. Now, the next step for us is to collect the outputs that we want to collect, right? So for collects, you see there is a data input here. So data is an optional input to collect any data that you have. This data is usually outputs of your script, but it can be more than that. And when we get to cloud computing and like how you run stuff on a cloud and then you want to download them later, it will make more sense. But for data input, and hopefully this is not as confusing, the component is not under Fly. The component is here under Pollination. It's called user data. It's to user data. I can do this thing. Yep, Control Alt if you can. So it's all the way here. Everyone were able, you were able to find it. Thank you for everyone who nods. That's really helps. I can't see your screens. So now in this script, we have 3 outputs. Probably you guys know how to do it already. So what you need to do, you need to connect these outputs to this component. And this is very similar to Fly. When you connect a new output, it just changes the name for you like this and like this. So again, the names pop up correctly because I have already right-click here and changed the names for my outputs, right? So, and I do not remember if we removed this limitation or not, but I believe we don't. Yes, we don't allow white space for your names. Sorry, you can always edit this in the CSV file if it doesn't look good, but you can only do dash or this underline. These are the 2 that you can do. So it makes sense so far? So what are you going to do next?
Plug it in.
Yeah, easy. So just give some space here, connect this data to this data. And now you can go ahead and fly again. Click fly. It says 3 inputs connected, 75. Do you want to go? It gives us some information about the stopping fly that I will talk about. But for now, let's just go. Now you'll see that you have inputs and you have 3 outputs that we connected, right? You have volume, volume to area ratio, and area as the output. Makes sense? And you have all the combinations. So it says 75. So here we should get 0 to 75, which is 76, because we have a header on top. Makes sense so far? You were able to write it and everything. So let's go and for once read what this fly is trying to tell me. Every time I just click and just ignore it, just let's go. So what fly is telling me is every one time that I click, it says, do you want to continue? And it says, hey, to stop the fly, or we should have probably, we don't need that here. It says, hold down the escape or delete this file. So the reason this file is here is wherever you saved your file, once it starts running this, going through the iteration, it will make a file called fly.ing or flying. And if you want to stop fly from going forward, you just go ahead and delete that flying and it stops. Why do you need to do that? Again, in theory, escape should work. But in practice, when you do this and Grasshopper is running, Grasshopper is one threaded, at least Grasshopper 1, Grasshopper 2 is going to have more. So when you press escape, the component may not pick it up. And then if you don't have the option to do that, delete that fly.ing, then you have to go and basically crash everything that you have done, right? You have to go and close Grasshopper and Rhino. And I know you guys thinking like, no, we are not that person. Like I check all the inputs before I start the study. You don't, I don't. We all have been there, you know, and it just happens like as soon as you say fly, the first one comes out and you're like, oh my God, I didn't set this incorrectly. So don't worry, you can go back there and delete this fly ing file, and then it stops. Someone had a question? No? Okay. So far, we set the inputs, we run the study. I have one question. How do you think Fly realize these are outputs, they're not inputs? So one answer might be because I connected them to data, but that's not the case. Because as I said, Fly is very dumb. You have always to tell whatever happens. It doesn't know what really happens. So the way to do it is, you see this small OP here? This is basically sets the type of this data. So it can be input value, it can be output value, and it can be an image. So we'll get to the image first, and then we talk why sometimes we need to use this user data to map our inputs. Makes sense? So the reason these things are tagged as out is because we basically, when we connected them by default, is the input is set to be an output. Any questions so far? No? Okay, great. So let's go and visualize this great data set that we have created. Very creative in a way. So if you want to upload this to Design Explorer, what you need to do, you need a CSV file. So you need to save it somewhere as a CSV file. And to do that, to make it easy, you can, of course, copy paste this, or you can just set a folder here, set a path to a folder, and that's where the file will be saved, that this as a CSV file. So I'm going to go ahead and set this to C/Ladybug AECtech 2024. You can name it whatever you want to name it. I think we support white spaces, but yeah, usually don't do that. So I just connect it here. And this folder doesn't need to exist. So if it doesn't exist, the component will create it for you. Just make sure you set it to somewhere that you have write access. So don't do it C/program files. That won't work. And once you did that, just let it fly. So I let it fly. There is one small difference here. Now that fly.ing file is under the folder that I created here, right? It's under C Ladybug AECtech. It's not next to where the file is. So basically, if you want to delete it, you have to delete it and find it and delete it here. So I just say yes. Everything looks kind of the same. But if I go here, now I have a file called data.csv. That should have all the information that we had here. So far, so good? Okay. So let's do this. In 45 minutes, we can upload our first parametric study to Design Explorer. Go to Design Explorer here. Go to Design Explorer, click on Get Data, and then there is a Browse option here. And you can go to the place that we created this, and then do data CSV, open it, and you can see the data here. And now you can create a static link, share it with other people, and tell everyone that if you select the maximum value for XYZ, it will be a higher volume. Such a great insight. that part I'm joking, but I'm just saying, like, if it was a meaningful study, then it would be basically the good thing is it shows the relationship between the inputs and the outputs. This chart lets you filter quickly. So let's say if you want something that has a very high volume, right? But I want the smallest volume to area ratio, said these two would have been my option, or these three are my options. Make sense?
So the way the Design Explorer knows volume, VA ratio, area are the outputs is because of the CSV header having the OP.
Yes.
Yeah.
Yeah.
Okay. But
Or
like
the
it has
out,
to be OP, out, sorry, out.
yeah, out, yes. So yeah, Design Explorer, the whole design is very, again, like, because it has to be as generic as possible, everything is so dumbed down. So there is no smartness trying to be smart. If you check on info, it basically tells you for developers or file preparation, it tells you CSV file has this thing. You can do in, out, and image for image.
Okay.
We don't support 3D in the pollination. And oh, and someone edited this. This 13 revision. Matt has been doing. Yeah, it has been years since anyone has touched Design Explorer, but I think the project has been successful because it got some of the very core ideas right. And there are many similar projects that started to pop up everywhere. These parallel coordinates started to show up everywhere in the industry after design, shortly after Design Explorer. So yeah, I kind of have a guilt feeling because I think some projects used it very wrong. But at the same time, I have seen projects that used it right. So both way can go both ways. Any questions? Any other questions? So far so good, but like this is not visual. Like I can select all this thing, but I want to see that image of the cube. So I want to see not only the numbers here, but I want to see the images. So to do that, what we need to do is to basically add one more step here to capture the image from the viewport. And then once it captures the image, we can connect the image file here as an output, right? And it collects all the image files for me. And then I can upload those images and I can let Design Explorer basically to load those. Does it make sense to everyone what we're trying to do? So to do that, Grasshopper has many plugins that can take a screenshot. So, and you can use any of them. This is one of the difference between this approach and what Colibri had to offer. Colibri was trying to do too much, if you ask me, like was trying to take an image and like do 3D everything. So now we made it like more flexible. So you can use any plugin that you really like to take the screenshot. So what we're going to do is we're going to use a Grasshopper Ladybug plugin. I think it's called Capture, LB Capture View. This one, you can see there is Capture GH Canvas. There's View Capture. Probably they do similar stuff. The only reason we're using this because I know how to use this more than how I know how to use others. There is nothing interesting there. So it takes a bunch of inputs. One that is important is it asks for the folders where to save the images. Make sure you save the images in the same folder that you save the CSV file. Why is it important? Because the path in the CSV file should be relative. So it should be a short path. There is no dumb question. Go for it. Is there what is OOTBGH node for file paths? What does OOTB means?
Sorry, out of the box.
Out of the box. Yes, you can
Yeah.
do file and this file path component.
Oh, yeah. Okay. Thanks.
So you can right
Sorry.
click here. Probably I should have done that. Yeah. But yes, that's the same. So you can use file path to basically select your file path. So I'm going to connect this to folder. For viewport, it basically takes the active viewport unless you put an input. So this is the viewport. One thing that you want to make sure for your views is because of how the UI of Design Explorer is, it expects you to basically do a square image. So make sure the UI is kind of like close to a square when you're capturing the screen. The other thing that's very important to make sure is don't create like, unless you really want things to be high res, you want to control width and height to make sure like you don't have very large images. Particularly if you run large studies, you want to make sure you just control the height here. So I'm going to do 600 for width and height. So then the last thing that I need to do is to set up capture. So I'm going to use this LB false start toggle instead of using the normal toggle. The reason I'm going to do this is because I don't want next time that I share the file with someone, if I set it here to true, and then they go and open the file, I don't want the component to work and set, this folder and everything. So the difference is this component, if you save the file and then open it afterwards, even if you save it as true, when it opens the Grasshopper document, it will be set to false. I personally think you should use this for everything that kind of does something, runs something before sharing your script. Otherwise, the other people open it, and I know like you should open it in a locked version, but people don't do that. So people open and like bad things happen on their machine. Everyone is following. Anyone needs more time? So we basically make this logic to run parametrically. We captured the inputs and outputs. We uploaded it to Design Explorer. And now we realize actually it will be much nicer if we could have added images to the visualization, so we can send something to people with images. And that's why we are using this component to create images. So now you see this component doesn't work because it's asking me like, you need a file name input to be able to run. So what would you do for file name? Of these images? Should I just call it like image or a screenshot and connect it here? And this is saving it, or is it? No, because this is saving it here. Anyone has any issues with this setup? No? Okay. If you don't have any issues, I don't have any issues too. So let's go ahead and then connect this as the other data that we want to collect. So I'm going to connect this here as data 4, right? It calls it a file. But before I run anything, I right click here, change the name to, I don't know, we can do screenshot or view1, up to you what you want to call it. What is important is to change the type to image, because this is like a special type, right? So you want Fly to know this path is not like just a text. This is an image file that we are connecting. Press save and let it fly. And it says 3 inputs connected. I want fly. Should I fly? I say yes, fly. So what happened? If I go to that folder, you'll see what happened.
Only the first image.
Only the last image. Because you didn't change, or we didn't, or I didn't change. I mean, you didn't tell me to fix it, so we all didn't change the name. Yeah, you're as guilty as I am. And basically every single time it is overwriting that file. And I did this just with a quick thing. So I was able to catch it after a few seconds. It's very common that people do this for very large studies. You just go ahead, run everything, and you think it's fine. You come back tomorrow, you just let this thing run overnight. You open that folder. There is one CSV file with all the results of all the simulations that you ran, and there is one single screenshot, the last one. And that's very sad. And you can't do much at that point. I'm sorry. You know, particularly if the result you were running locally and you were overwriting the same folder because you didn't want this thing to just go out of order, because every simulation can take a lot of space. Because of that, when you're running the studies and before doing the full fly, always try a test fly. Run a test fly. And I know you're not going to do this. It's okay. But first time that it happens and things go wrong, probably you will listen to me. So the test fly, we put it there because it's very common, and it's not only image. It's just like you do stuff and usually you're under pressure and you want to just set this thing to go, you know, and like you solved everything and you just say, let it go, I want to leave. But just take your time, do test fly. What test fly does, it basically picks 3 items randomly and runs that 3 combinations for you. So you can run 3 items, you can check all the results, make sure everything looks fine before running that very long study that can take forever, right? So now I'm going to do a test fly. The other thing that's happening is pollination realizes, or fly component realizes there is already a data.csv file there, and asking me if I want to overwrite that, right? So you don't want to suddenly, excuse me, overwrite all the things that you already executed by saying, like, you know, selecting the same folder. So now if I say yes, you'll see it says only 3 iterations will be done, and it runs 3 of them. Then I can go to the folder and say, oops, I forgot to change the name of the output, so all the images are overwritten. If you're running a real study, you want really to go open this 3 and see if the results make sense, if the screenshot is correct. The other thing that I have seen, and I have done too before, is you forget, and you know, you do like before just running, you make it like you zoom in, zoom out, and you forget, and then you do all this, and all of them are captured in the wrong, you know, with the wrong thing in the viewport. That's why the test fly is very important. Okay, we did the test fly. We know we made a mistake. How do you fix it? The ones who have used,
Give every image a unique name, a unique number or something, based on
right,
number of iterations.
right, and the way we used to do it, probably you see in a lot of sample files, that if you see, or even tutorials, is like we use this text join, and then we connect, you know, underline here, and then we try to basically get every input value connected here, the name of the value, and then the value. So no need to do that anymore. That's why you have the ID. The ID is basically that unique value that you need. So let me connect this ID here to this, and I will answer. So instead of using the file name, like naming the file name, you basically parametrically generate this file name from the ID. So this file will be named this, right? Name, value, name, value, name, value. Allah, but the image of the viewport in the test fly is not saved. What do you mean by that? I need more.
I mean, the test that we've conducted, the 3 samples, the photo that was last fixed in the viewport is not saved in the file path.
Here, you can't see the image PNG there. You couldn't.
Mhm. Yeah, I see the one from the.
You see the one. So let's do this. Let's just delete this in the folder, right? If you go ahead and do another test run, again, I'm not running it. I do another test run when I'm fixing because I don't want to wait forever. So if you do the test run, do you see 3 images there?
Yeah, I think I do now after I've taken the output of the ID.
Okay, great.
Yeah, thank you.
Yeah, no problem. Everyone is getting this, and like I saw, the viewport wasn't correct. One thing that you can do here for viewport is you can also use saved views or named views in Rhino, name viewport. I forgot what it's called. What's it called? Named?
Named views.
Yeah, named views. Yeah, you can use named views to create a specific views and then use those as the name as an input to viewport. So you make sure it gets like basically the view is set correctly. Okay. So we're all set to go.
Could you give it multiple viewports as well?
Yes, you can.
Okay.
And it will generate multiple files.
And then it appends the viewport name by itself. Okay.
Yes, to image. So basically you will have one here and then another one goes as view 2.
Okay.
And then that will be connected. So are we all set to run the study? Anyone has any comments to make? What is this thing that they say in the weddings that say anything if you otherwise you can't say it forever? I mean, you get the chance to say it now.
Speak now or forever hold your peace.
Thank you, Chris. Yeah, speak now or you can speak in 5 minutes. It's fine. But for now, if you don't see any issues, you can just go ahead and run this. So you can do fly. Yes. Yes. And then it should run everything. And it should generate you see now it has another column here. It's called image view 1. And then this is the path to the image that we have. So now I think we all wish that we could have just gone to Design Explorer here and uploaded the new CSV file, right? And then see all the images. But it's not going to happen. The reason it's not going to happen is because these images are basically locally on your machine. And what you need to do in this case is to upload all these images to a Google Drive or whatever Microsoft equivalent of that is.
OneDrive.
Yes, OneDrive. Thank you. And then here you can basically load data from that Google Drive or OneDrive. So this is kind of like a very annoying process to do. And this is something that we are working on to improve. So I'm going to show you what we are trying to do. So for now, you actually have to do this. So what you need to do, you need to go upload all this folder that we have, all this folder that we generated. You have to go and upload it to a Google Drive somewhere, make it public. After you made it public, you go to Design Explorer, go here to get data, and then load data. and then it will show up, right? And then once it shows up, you can basically create a static link here and then send it to people so they can check it there. But it would have been great if there was an easier way to basically stay in Grasshopper and do everything from inside Grasshopper, right? So you didn't have to do all this manual steps. So that's what we're building towards. It's not finished, but I'm going to show you, and you don't have to follow here, and I have already done it. So pollination has a cloud computing aspect to it, but it also have a web interface, right? If you go to app.pollination.cloud, you will see there is an option for app gallery, which means you can build your own apps. And one of the apps that you see here is Design Explorer. So you can click on that and you can go to app, which will open this app for you. And I give everyone a few seconds to get there. So this is the app that we have developed, or to be more specific, Mikkel has developed. It's anyone here is a developer, codes and knows Python? Okay, we have. So if you know Python, if you go Pollination Apps Design Explorer, so if you go to GitHub, Pollination App Design Explorer, I see Mikkel is reverting some change. So I think he made a change that broke something. It's okay. That's how we roll. So that's the code here. If you want to edit it, if you want to deploy it on your end, it's basically a Dash app. That's the technology that we use that you can also use and build the UI. So the idea here is, instead of having people basically do all the things that they need to do and go to Google Drive and everything, they can just upload it to pollination projects. We have a component for uploading asset, this one, upload assets. So basically you can upload the stuff to a project. And then once you upload it to a project on Pollination, then it has all the permissions set to it. So you can basically put it in a private project that you have, and anyone who has access to that tech, with Design Explorer, the public version is you have to make your data public to be able to visualize it. With this, you don't have to do anymore. So now we have a project already in Pollination called Sample Parametric Studies. And Mikkel will tell me if it will be fine if I open it. So there are two options. You can upload the whole folder, or you can zip everything. So I just opened that zip file, and here you go. I have my options, and these are the boxes that we generated. Some of the images take some time to load, but they're there. Makes sense, everyone, what I'm trying to communicate here? So this is kind of like, so far you can see it as you can use Fly and you can use it with Design Explorer. That's what right now you can do. I believe it's much easier to use than the Ladybug Fly, and it's much easier to use than Colibri. It's just two components, and this one, three, that does all of it. But where we want to go is we also want to remove that need for you to upload the images to a Google Drive and wait for it to be public and all those. So we want you to run it, just upload it to Pollination, and you can load it from the app quickly. Any questions? I see some faces having that after lunch, didn't have their coffee and tea kind of look, or dinner. And we are, so this is 3:11. I will give you a break at 3:30. But let me just go through some of the options that we have here that for real life projects, they'll be useful for you. The first one is, in this case, we kind of got lucky, and the images are actually matching the order. So it's X2, Y1, Z32, like this. But there are cases that I have worked on that the script is more complicated, right? It runs some daylight studies, it wants to do all this stuff, and the order of the components are not correct. So what happens is Fly basically makes a change here. This component gets updated, and then it triggers, at the same time, triggers this, but also triggers this component to take a screenshot. And what happens is this component takes a screenshot, but the image is from the older study that you had, because the study hasn't finished yet, right? So this can take an image of your previous version. And that can be really confusing because you load the stuff and you're just like, God, this result doesn't make sense. To do that, to control that, so one way is to push this component, the order of this component to be executed after everything else. And now you can see it does actually. So the way to know that in Grasshopper, if you just move and you see your component is on top of, like shows on top, that means it will be executed after this, unless you have a relationship. So this means this component will be executed after this once, right? But if I press Control B, the component goes in the back. Now, this component will be executed before this wants to be executed. And it's just a matter of like how you inserted, dropped your component on canvas. So it's very risky to just rely on the order. Yes, you can press Control F if I'm remembering this correctly, and Control F will bring your component forward. So it will be the last one to be executed. But I personally never rely on that. The way I do it, I basically add an additional connection from one of the results or one of the components to this component. So I make sure this gets executed after this component, in Grasshopper terminology, expires. It means you get a new value and it says, okay, I'm done. So to do that, what I do, I usually use an OR gate, or gate OR, if you double click and type OR. Actually, sorry, I have to use an AND gate. AND, so it should be this and this. So this is a little bit tricky because if this thing that you connect has a value of 0, then it will be false. So you can do plus a number or something. But what I'm trying to tell you here is just to give you an idea of the logic. So what you really want, you want this capture view component to have a dependency on one of your outputs. So it gets executed after this output's being refreshed. So you make sure the order is correct, so you don't take the wrong screenshot for the iteration that you run. Make sense? Sounds good so far. Okay. Any questions? No. So the next thing that can happen is you go, you set this thing up, you run it locally, you're happy, you think everything will be fine. You come back tomorrow morning, you see a blue screen. Or you were running it on your computer and it has, like, you know, the storage, you were saving it to a folder and the folder like ran out of storage, so the study stopped running and all those things. Bad things happen in real world. And because of that, now you need to rerun the whole study. And if your study is taking a long time, rerunning them can be really like time consuming, right? So you don't want to rerun everything. You just want to rerun the ones that haven't been executed, right? To do that, there is an option here. There is a right click here that says add to existing if new. That means only run this and add it to existing ones if it's new. So if it goes and reads that CSV file that you have there, And if it sees there is a record that has the values, that has the same input values, it says, okay, this one has been already executed. I just go to the next one. Does it make sense? That's one thing. The other case that happens is you run all these studies and you're happy and you send thing to people and people go to Design Explorer and they're like, this is great. And someone comes and says, what if we run it for 2 more parameters? And you're like, okay, now here we go, right? So you want to run it, but again, you don't want to rerun everything. So in this case, it's kind of similar, but in that time, you might just set a new set of sliders, right? And what you can do here, you can also set this or select this option. This says add to existing. This basically appends the new options that you have to the existing ones. This is also useful for when you're running thousands, right? And running 1,000 option next, like all together in one study, particularly if you're running it locally, it's very bad idea, probably never ends. Even if the study is very simple, Grasshopper just gets very slow after running so many iterations. So what you want to do, you want to break them down. And this is helpful to add to existing. So you basically, you have it running and then it adds it, you run the one patch, the first patch, and then you run the second patch and you add it there. And then you have this option of create from scratch. Create from scratch is basically just ignores whatever is in your folder and overwrites everything. You know, don't select this. Normally, the default is confirm is if exists. That's why you saw when I was trying to run the test fly, it was asking me that saying like, oh, this already exists. Do you want to continue or not? It looks like we have a bug because when I was running it the normal way, it should have also asked me that this folder already has a file. Do you want to continue? Makes sense? The 4 options that we have here and why we have these 4 options. Okay, great. Any questions so far?
I do, although I haven't done this, but when you say when you have a very large model and then you need to break them down into batches, what are the normal logic you would use? Like, for example, if you are running from 1 to 5, like on axis, and then do you just run X at 1 and then the other ones are like, how do you normally break
so
that
then
down?
this will be 5 to 10. How did we use to do this? 5, 10. I have not used Grasshopper for a good amount of time.
It does.
5 less than 10.
Dot. Yeah, like this.
Or,
Oh, 5 dot 10.
or you can use less than 2.
Yeah, less than. Thank you. So yeah, this is how I would do it. So this will be my second. Or I'm going to show you to run this on the cloud so you don't have to do this. So that's another way to do it. But yes, this is basically you break down your, what's it called? A design space, all the possibilities. The other one that you can do, which is this fly component provides, which I think is pretty smart. And I wanted to show you in the next example, but I'm going to show it now. Recent files is to use this component. So let me go back here. Oh, that's for so let's say this component is valueless and you can basically have, you know, options with values. So one of the things that Fly understands is, so let me connect this directly right now to Z. So you see the number of options are 75, right? Now, if I disconnect this, so it understands these are not selected, so the number changes. So it only runs for the active ones. So you can create a value list, and then you can basically in your different files, you can, for the first one, you can run all the short ones, you know, then you can have another file and run all the medium ones. You can have another file and run all the long ones. Make sense? And I see this gives me an error. Range of valid values. Okay. Yeah. So any other questions? Okay, so if there are no more questions, let me just go ahead and give you the last thing, and we still have 8 minutes to 3:30, but I'm not going to use that. So one other thing is that sometimes you will have a logic that when things get complicated and things get complicated, that you don't want to have a button. So this is something that by design, we made it a button. So you don't do by mistake, connect a Boolean and then you make a change and it just starts flying everything and then crazy things can happen. That's why we put it a button. But there might be cases that you want to trigger it like any standard Grasshopper component. And that's where you can do enable fly input. And now fly input changes to a normal Boolean toggle. So you can basically do that. What does it say? Oh, you can use a button only. Sorry. I think that's another thing that Mingbo has added as a way to make sure like you don't leave this connected to a Boolean toggle that's true. So now I should be able to use a button. I click this and it asks me the question, one is available, do you want to continue? I say yes, and says like 75 thing, do you want to run it? And I'll just run it. Any questions before we wrap up the first part of the workshop? No, makes sense. Okay, so quickly what we learned is, hello, where is it? I can't find my presentation. So from here, we did this, right? I will copy this file so you can have it if you didn't have a chance to follow with all the details. But basically we isolated, right, inputs here. We learned how to collect the outputs. We learned all the options that Fly has. So all you need are 3 components: Fly ID, and user data. Then Design Explorer supports 3 different data types. There are inputs, outputs, and images. Everything is designed to be very generic and very dumb. So you just change the header in that CSV and everything changes. Run a test fly before taking off. Like everyone raise your right hand. I know you're not going to do this, but try, right? Run it, run a test fly. You promise me. Don't do that, readers. You're better than that. Then, oh, this one shouldn't be here. Like, yeah, this one we talk about after. I copied it in the wrong place. But this is basically all we needed to do so far. And then don't forget about the Fly components right-click options. So you have several right-click options, again, to append to an existing study, to override, and all that. When you come back, we're going to do more Ladybug Tools stuff with the same logic. I'm going to copy this file for you. It's basically a very small, simple box. I saw Chris already shared with me a large model, so I'll see how I can kind of push that in the workshop to also show you how to run a large model, because people want to see that. So we kind of like run this parametric study, and intentionally I kept it small to show you like best practices more than waiting here for the things to run. Any last minute questions? If there are no questions, it's 3:26. Let's take 14 minutes. So be back here at 3:40 or the equal of that at your time zone. So it's around 15 minutes. I'll see you then, and I'll be around to help if you have any questions.
Thank you.
Yeah, no problem. Thank you. Okay, so you can see my screen. Yes. So yeah, there is a file. I uploaded it to the shared Google Drive. So if you can go there and download it, it's called 02 Daylight Example, and download it. Maybe I share the link here again for everyone to. And I didn't get a chance to check the file that you shared with me, Chris. Should probably have clicked on it.
It's just a 3DM file of the large Revit sample model that has sensor grids already. So
Okay.
you'd still have to set up the the recipe and everything.
But it's like a HPG, like it's a
It's
model,
a
right?
3DM file, but yeah, but it's a model. It has all the properties.
Okay, perfect. Thank you. So maybe I can show how to use that. I mean, there are shared topics that I want to discuss anyways. So everyone has this file open. If you don't have the file open, let's see how I made a mistake in this simple example. So this is a very simple example. I intentionally decided not to use a large model because again, like I want to focus on, like I want us to be able to make mistakes quickly. So I don't want model to be large to deal with the large complexity of geometry. But this is a simple box, right? Room. Then I create a room from that. The values are here. The parameters, input parameters are 3, window to our ratio. You can change it. Shade depth, you can change it. And shade count. So you can have 2, 3, or 4. I already showed you how to do, a list. So if the value is you want to select 2, I don't know, 7 and 10, you can just type them in a list and connect them. So yeah, I'm not going to do that here again, like just connect to the sliders. Then this is the whole thing up to here. And here you have a model that gives you with sensor grids. The sensor grids are created here using this component. I selected 0.5 meter and 80 centimeters. That's why your model should be set to meters here. Can you check and make sure if your model is set to meters in Rhino? If not, then type units and change the units. Or is it units? It didn't work for me.
It's units. It might just be behind a few other things.
Yeah, I don't know where units are. But in a normal world, units shows up. And let me close Grasshopper. Where are units? Here you go, hi units. So it was on the other screen. So you can basically change it to meters and then go ahead. And once you change it to meters, rerun the script, right click here and recompute to make sure everything, basically Grasshopper knows that the units have changed in Rhino. If you do that, then you're ready to go. So this is the model. This is the component that I'm using to visualize it. And this model has only what, like 960 sensor grids. We can play with this, or we can use the other larger model to run some studies. But my goal here is, again, now to take this one and run daylight factor studies and get the like the mean value, the average value, MEAN, for the room, for daylight factor. And then we can set a goal there and see, like, if we meet that, and we can check all the other outputs of the study too. So this is our input, this is the logic, but it's missing the part for running simulation. In Ladybug Tools world, there is a concept of recipe, right? You just go, you connect this to the annual daylight recipe and you run it. In Pollination world, there is a similar concept, but it's a little bit more nuanced the way it works. So in Pollination world, to bring a recipe, you use this component setup runs that I asked you to use initially to log in. So you should have it. You bring setup runs and then you connect on get a recipe. And it should open a window for you like this. And since you are under your personal account, it will just show you a bunch of recipes that you have. Let's select daylight factor and go ahead. With running the study. So this is what you would do, right? You bring this, double click, select your recipe, and you run the study. Is that okay so far? Were you able to find it? The component is this. Click on get recipe and get the recipe.
So the number of recipes available is dependent on the type of account, right? Like free versus paid, or
No, like you get access to all the recipes that are available for publicly. If you're part of an organization, then you will get access to the recipes that are private but are part of that organization. We do not limit, as Chris said this morning, we're not going to limit you, for the running things more accurate or having access to be able to see the source code based on being paid or not paid. So everyone has access to all the public recipes that we have on Pollination. But you were getting onto something that was good, but it's okay. There's something else going on there too. In any case, so I have this, then it has inputs. You can hover your mouse. It tells you about different inputs, right? You can connect them. So for this one, the only required input is model. I connect it here. And then for running this, unlike Ladybug Tools that has like everything happens in the same component, in Pollination, there are two steps. One is the recipe itself. The other one is you select this pollinate component. And this is the one that runs it. So what I can do, I can connect this here. It's a single run. And I can go ahead and click on Pollination. But before doing that, for the first run that I want to do, I want actually to run it locally, right? So by default, you see this up here? Pollination runs this on the cloud. You can right click here, and as simple as this, you can change it to run on local machine. Right, so I just went here, and this is now look like a local machine. Now, if you go ahead and run pollinate, on some of you, you should get an error. For some of you, it might run. So I'm going to go ahead here and click pollinate. And this will start Queen Bee EXE and start running. So how many people faced issues here? Getting something red. Chris, what's the issue? Is it real? For real?
In my case, it's just because there was already something in the simulation folder. So it didn't want to erase it.
Right.
So yeah, I just had to go in and manually delete unnamed, and then it worked.
Wow.
Did anyone else get that?
Is it running for everyone? Yes?
I don't get the queenbee.exe
It
command.
fails. So do you see any errors? Is anything pops up?
Nothing pops up. It says running and then pollinate, but like no other window shows up. So it's like,
Oh, is it on your other screen?
oh, maybe. No, I don't think so.
Or did you? So a couple of questions here is where did it run?
Right.
Right. And how much resources did it use when I ran it locally? So intentionally, I just ran it because that's what people do, right? But then if you see any errors, I was expecting some of you see an error because the place that it runs it is somewhere like to program files that you cannot run studies. So the way it is, if you right click here under the Pollination run settings, there are settings for local runs, right? One is the number of CPUs. This is usually set the number of CPUs that you have on your machine -1. Like mine is 22. That's probably too many for this room. And that's something that we'll talk about. And the other one is Ladybug Tools folder, from where it should load all the Ladybug Tools libraries, which by default is C/program files /Ladybug Tools. If you use the Pollination installer, everything is there. And then working folder is where it saves the result, right? So in this case, it's usually set to your user folder /simulation. If you want to change it, you can change it here.
Yeah,
So,
I forgot to check the run local machine.
Oh, you're running on a cloud. Well done. So that's good.
They're multiple running on the cloud, I can see.
Yeah, you can see it's good. Like, that's why we do workshop like this. We just see what are the things that you do wrong. So, yeah, if you forget, and this is something that I have been actually thinking about. Maybe our default should be local, and you switch to cloud instead of local being cloud, and that might help. So one thing, don't forget that. The second thing, don't forget all those folders. But then if you run it, that's the beauty of here. This is the beauty. It doesn't matter if you run it locally or you run it on a cloud. As long as it's finished, then once you submit a study, there is another component here, what helps you to check the study status. So connect this here to this. So in this case, the status is nothing because it was local and it's done, but there is a finished run here that says it's locally ran under this folder. So we have first component, get the recipe. The second component runs it. The third one is the one that you take care of, like basically gives you the status while it's running. And then you can see, even though this is a study, there is one finished run here. The thing that happened is you can actually connect more than one run when you do a study, and that's what the parametric stuff comes in. But here we have a study with a single run. Make sense? That's connected. That's why you only have one output here, which is totally fine. And then what you can do now that you have finished run, you can get the outputs for that run. The component for that is called check run results. So this component has three outputs: grid metrics, results, which is the result folder. And you can see if when I hover my mouse, I can read. It said daylight factor values. These can be plugged into LB, a special heat map component, along with meshes of the sensor grid for visualization. And then visualization, which is a visualization set format. This is for the ones who were here this morning. This is the new visualization set output. So you get a default without doing much work. So you see there is a star here around it. So whenever you see that, that means this is a file and you need to download it first. I know this feels like so many steps, but hopefully it makes more sense when you see run something like cloud. So you have one more step to go, and that's this component to load these assets. So from wherever they are. For this case, I'm going to only get the visualization first. So I connect it here. What it does, so let me check the output of this. It basically takes whatever this thing is, and it tries to load it. It tries to first download it locally if it's on the cloud, or if it's local, it basically gets the same file path. For some outputs, there is an instruction in the recipe that says read the value and give the values out. For this one, there is nothing, so the output should be also the VSF file. And this VSF file, VSF stands for visualization set format. This is something that you can take and visualize right away. The way to do it is, everyone has this PO visualization set? Or do you? So if you install the Rhino plugin, you should have it. There is an equal component in Ladybug 2 that we can use. But then I connect this visualization set here to here. I press Control Q, and the result is here. If you don't have this component, or if it doesn't work and you don't have a Rhino license, the component called LB preview visualization set. This also does that with a little bit of a difference. So you can either use this or use this. Give me a thumbs up if you're done. You're good? Mostly good. So I can share the file with you. There is one that I already have everything set, or mostly everything set. For this one, if someone wants to, if you're behind, you can also go to the folder and get that. It's called, oh, it didn't work. Okay, the file is there. So what happened now is I basically took the model, I selected my recipe, I ran the recipe, I have a component that checks the status, I get all the outputs, and from the outputs I got visualization, so that's good. I can generate my images that I want. But the other output that I wanted was metric, like I wanted to get the mean value for the room. And this one says it's a CSV file that has all the grid metrics. So I can go ahead and connect this one here. This is my second output. And here in grid metrics, I can see it gives me several values for this room, like the mean value for this is 321%. Then the minimum value is 0.36 and the maximum is 15.8% in this room. And so I don't remember what's the required value in Europe standard. Anyone here remembers as a goal? Let's say come up with something. On average, we want 2.4. Let's see, like we want to find we want to run this study and our goal is to go to 2.4, something like that. Makes sense to you so far? Yes. So if it does, I'm going to give you 10 minutes to make this parametric. So use the fly and everything that you have learned. So our goal is to take the inputs and get all the way to this output. And for output, I would pick mean. That's the one that I wanted. But if you want to pick more values as outputs and add it to your Design Explorer chart, you can do that. And it's you have 10 minutes. And how many options do we have to run? You don't? You have
36.
I don't remember, yes, 36. But how many are you going to run? That's not a trick question. You're gonna run 3 because you're doing a test fly. You're not going to run everything. Remember, we talked about that. All right, 36 is good. So here is CC, for example. This is your run. And oh, you've run 3 back to back. And I can go here, and because the project is public, that's one of the things I can see your simulation here. So you can drop off, you already ran something on a cloud. But that's something to be careful because in this case, this was a room and it didn't matter, right? If you don't want to send your office project to Pollination Cloud.
And
But at the same time, this is cool. Now you run your simulation without doing anything outside Grasshopper right away, and you can share it with anyone. Yeah, Allah also, you're on a cloud. I mean, not to mention that you can copy paste. Three more minutes, or actually 2. One more minute. Were you able to finish it? I mean, it's okay if you couldn't. Like, how far could you get? Just wanted to. Mainly, we're doing this for you to do it on your own and let me know what are the things that didn't make sense or what are the things that you did wrong, or if you have any questions. Okay, 410. How far did you come to the process? Were you able, anything that doesn't make sense? Overall? Christine?
I have a
Oh,
question.
go ahead.
I was able to plug it in and let it fly and open a folder, and it has the data, but not the view capture. What I did notice though, when I ran a test fly is that like my check study status and kind of everything after that just flashed orange 3 times. And I'm not totally sure if I'm missing something.
Yeah, you're not. It's just like I let you make a mistake. It's my bad. So, okay, so you were able to set it up and things work. So let me set this up quickly. Remember, you get all your inputs, you connect them here. Then you use the list item component. You don't have to follow from here. You can just chill. This is the last 45 minutes. I'll just go through things and like basically try to show how things needs to be done. And you all get the recording so you can follow here. So remember, you zoom in 1, 2, 3. Window to our ratio goes to window to our ratio here, right? This one goes to here, depth, and the third one goes to here for shade count, right? So I have the 3 connected, and now they're connected to fly ID. So now that I have the ID, I have to let it fly, right? I connect the ID here, and I let it fly, or no, I just go run a test fly quickly, and I can see, okay, it went 3 of them, and it looked fine. Then I have to collect the outputs. I come here, and I want to get the outputs. For getting the outputs, I need to run one study, right, to be able to see them. So I just go here and click on pollinate, and it just runs one. I wait a little bit. Okay, it ran it. I can see it. And then for result, the sample file that I shared you has a Python component in it that basically you can select them, like as a list and do all the Grasshopper things to load them. But I find that a little bit annoying. So I basically put a small Python script together that does that. What it does, it takes all this metrics in, then you basically say what you want here, and then it gives you the value for that. So this is what it does. So it's like 267 for this. If I want to get more of this, I can just say, you know, give me this. I like that uniformity ratio as a helpful output. So now I have two values here, right? Then this is just basic Grasshopper again. I'm going to do item, list item, get the first one and the second one, bring a number output. And here I'm going to name them basically. This is the mean value, and the second one is going to be the uniformity ratio. So you connect this to this, you connect that to that. And now for collecting data, what you're going to do, you're going to use this component called user data. So I just connect the first one, I connect the second one, and it gives me this thing that you can't have the white space. So I have to fix that. I can connect it here, right? And then what I can do, I can also take a screenshot. So the difference that you see is default is this one basically puts the legend parameters here, but you can change it. This one by default does put it on the side. If you're doing this for real study, you have to change this. You have to make sure you use legend parameters to fix that range, right? Now the result is going to be all over the place. Because of the time, I'm not going to spend, I don't know, is it easy enough? So legend parameter 2D, let me, legend, this one is the one, Chris, right?
Yep.
And
Yes,
where do I
it's
set 0, like the domain?
You can just plug it into the component. Just plug it into Legend Part 2D. And
No,
then
I know, I want to set the minimum to 0 and max to 5.
Oh, that's under the normal Legend Par. So
Okay.
both of them operate with you.
Okay. Legend,
Yeah, so just Legend parameters.
LB, legend parameters. Thank you for your help. So I'm going to, and I hope you guys you see, like there are things like this that I know this is a workshop. I know the result doesn't matter. I know that we just like, you know, have less than an hour, but still I can't get to like not fix this because this can give you wrong understanding of the results. So yeah, it's like be careful about stuff like this. Make sure you set them correctly. So this is this one, and for image, I'm going to do what I said. Like just go ahead, and you had an old file, cube example, and copy paste all of this. I'm going to paste them here. So for file name, by now you should know what you do. You basically always use the ID. And Grasshopper now has this thing that you don't use it enough. So you can double click here, just relay. So I can do that. And then I can call this AECtech daylight. Okay, and now I have everything set, I think, right? For this thing, I want to connect it to something, right? So I'm going to connect it to this. So I make sure, like, what's that? The uniformity value is never 0. So it only triggers if I have the 2. I set this to AND. This is giving me a file. I'm going to connect the file here. I'm going to make this as an image. And now I have everything that I need, right? Anyone has any, and I have to connect this also to the folder here. Anyone has any comments that they want to add that should I be running the test fly? Yes,
Right.
no, maybe.
The test. Run the test.
Run it?
The test.
Okay.
You want to run the test first, right? I don't
Yeah.
know.
You don't know. Okay. So at this point, no one trusts me. That's the goal of the workshop. Don't trust anyone. Test it. Run a test fly. Yes. What just happened? Nothing happened here.
It's
This
not
didn't work.
running the pollinate.
Yeah, it doesn't run the pollinate because pollinate needs a button to click. So what you can do here, or you need to do here, you need to right click here and change that pollinate to be an input. If you want to run parametric studies, it needs to be an input. So you can toggle this. Connect it here. Run it. And you can close this if you want, the first one, because you don't want to run that. And now if I come here and fly, no, because I want to test fly, right? Run a test fly, yes. And this time this should work as expected. So one thing that happens is when you run it locally, this blocks your grasshopper, and which is expected, right? And it runs it one at a time. So now I can wait here. I see I have a bunch of things that basically the screenshots that were taken. So this is the first one that comes in. Now here's your chance. If you see you have made any mistakes, this is your friend, right? You just delete this flying file and it can basically kill that. So I can see the first one is 0506 and 4. So that's 0506 and 4. Let me see if it makes sense, right? Like that's what you need to do. If your studies take a long time, that gives you enough time to go and check and see if the results make sense. I have the values that I want here and all that. So it ran the second one. It's a good test. So if I feel good about it, I can just stop it and then I can run the whole thing, right? So we just learned how to run this locally. You can basically take this data CSV, you can take all the images, upload them, and you have your parametric study done. So now, if you have no question, how do we run this on the cloud? Answer? So the way to run this on the cloud, you can say, let me set this to false first. I can right click here and change this from running locally to run on the cloud, right? And then what will happen? I basically submit the study, it runs one. What do you think happened next? It runs the second one, what will happen? So the way this is designed when it runs on the cloud is this component is not going to block you. So if I start running this on the cloud, you double click, it actually starts running on the cloud, but Grasshopper is still working, right? This thing has been submitted, this thing has created the study, and the study is already started to run on the cloud, right? So if I go here, check a study to load. The study is running under my project with a random name. This already started running. So if I start running this with Fly, what really happens is it's not going to capture one by one. It's just going to quickly go through and nothing is really going to be collected. And there is not that much benefit for me if I run it like this. So what I really want to do, I want to collect everything and then submit them all together in one go to run on Pollination. So everything can run in parallel. Does it make sense? Because I'm not going to use cloud like local one at a time. That just makes no sense. What is the advantage? Yes, it might run faster on the cloud, but that's not the real advantage. The real advantage is when I can run everything on the cloud in one go. So the workflow for that is basically you're going to separate, you draw a line here, and you separate submitting the study from loading the results. So anything about loading and post-processing is going to be separate from the part for loading the result. So now you see that's finished, this thing ran and all those stuff. So let me do this. Let me remove this. So I'm not interested in running one study at a time. I'm going to also remove this to go back to be a button. And what I'm going to do, I'm going to create these iterations, but I'm not going to submit them to Pollination. What I'm going to do, I'm going to collect them and then submit them in one go. So what I'm going to do is I'm going to come here and use the record data recorder component. And I'm going to record all this stuff. And then after recording them, I'm going to connect all of them as a single run and let them go, right? Anyone has any comments before I let it go? And in this case, because I am basically don't getting any of the outputs, right? I basically need the fly to be like this, right? I can delete this. I don't remember if you can multiple. So what I need to do is fly goes here, and I'm just going to collect this ID, right, which has all the inputs, and then run them. And this time, I can create a folder, but how do I collect all this input data that are related to that model? Anyone has any suggestions? You can say you don't know. Okay, you don't know, let's run it. So what I'm going to do, how confident you feel? Should I run the whole thing or should we run a test?
A test.
Always run a test, thank you. That was a trick question. Run a test fly until you know everything is correct. So I'm going to run a test fly, yes. And what's going to happen, it basically ran through that 3. If I check here, there are 3 runs that are collected. And I'm going to submit it to Pollination. This time it says there are 3 of them. Maybe I want to name this so it doesn't go there with some random name. I call it test run with 3 options. That's the name of the study. I can add a description. I'm going to go pollinate. And it starts running. And now if I go under my account, under demo, there is a new study submitted that has 3 options running, right? The good thing is, some good things, right? One is like this thing is not blocked. I can continue working, like you can continue working. Everything is submitted. The other good thing is everything is running in parallel. So if one study was taking some time, now 3 of them are going, you can see 5 out of 10, 5 out of 10, 5 out of 10. And once they run, you can check the results, and then you can tell me if anything is wrong. Or you can even check them now, because as it's running, and that's one of the other good things about Pollination running on cloud, is I can come, so let's say whoever submitted this, and I'll show you how to run it under your project, but now I'm running on my personal account, it's public project. I can click here, and while it's running, I can click on inputs, and I can see what are the values here. I can check the model. So it's like 2 something. Let me check this model. Okay. And let me check this model. That looks very similar. So it's done already. I have 3 options that ran, and you can see like this took like 1 minute 34 for 3. Probably took about the same for one model. Yeah, 116. And this is kind of like where the value of things start to show up. Like, because you can run things in parallel, and as you scale up, it's the time that it takes to run one study in theory, right? That really counts. And that's where things can scale up. So let me go now, and then don't tell you anything, and just go and load the results back so we can check the result and see if they make sense. So what I can do, I go here. Again, I told you like now this should be separated. So I'm going to disconnect this. I'm going to bring all of this. And again, you don't have to follow, right? Just on your end, just see how it works. So the way to get the results back is now I need this study. And if I can get this study, I can basically go through all the things that I got from the study, and I can do the same visualization. So the way to get this study, there are different ways. You can just type it, honestly. But if you want to do something like more cleaner, let's say, or more official, we have a component that is this one that lists all the studies. So I ran this under my default project. I didn't mention it. I'll get back to it. But that's one of the mistakes that you make the first time. When you select the recipe, you're not careful and just run it under your personal account. So one of the things that you want to make sure is to load the recipe from the correct account. I'll fix this for you, don't worry. But now it's under Mostapha demo. So the project is called, so connect it here. And it loads all the studies. And because it's my demo project, probably I have many of them, right? And that's why I named it, because no one wants to go and check this UUID value to see like which one was which one. So you can see the first one is like test run with 3 options. So I can select that first one. And connect it to study. And this time you'll see that this thing is loaded, right? And now instead of having only one option, I have run index here. So I can go between these 3 different things that we ran. So I can bring a 0 to 2 slider. And if I animate this, let's use the fly component again. It should go through the things that I want. It should give me the result, and I should collect everything, right? But things are going to go wrong, unfortunately. So let me start doing it. I bring the fly ID component here. This time there is nothing, it's just run index that I connect to it, right? So I call this. Now, I get some values which are not that useful. I get the output here, but I don't know what was the inputs that I passed to get this. Does it make sense? So for me to collect the result and do our visualization thing, I can get the, sorry, I can get these values, right? The mean and ratio, but then if I want to connect it to Fly, what I'm going to do with the ID, like where are the input values that I set? Make sense? So if you want to load the things on the cloud, there should be a way to know the parameters that you ran, what were the input parameters that you ran. And those values are not there because I didn't send them to the cloud. The other thing that happened is, and if we had more time, I would have spent more time before I tell you this was a mistake, is that when I was copying this, let me go here and check the inputs. So when I ran this study on a cloud, if I go to inputs and model, I got 3 models that are unnamed something, right? And because they're randomly named, they didn't overwrite each other. This was something that we put in to make sure people don't make a mistake. But really what I should have done, I should have named this based on the input parameters. So when I go on the cloud later, I can understand which model relates with which input parameters that I had here. Does it make sense? So that's where the magic of user data come in. So what I need to do when I was running this thing here, I had to do some stuff differently. And I made all the possible mistakes here that you are going to make too, and that's totally fine. That's your first time. But next time, be careful about them. One, when you load the recipe, go to the project that you want to run the study for. So for example, what I have done is for this workshop, I have made under extended trial project. So if I go here and go to projects, I have made 2 projects for this workshop. So if you go here, you should be able to see this project, the demo project, and the shared project. So the demo project is the one that I'm going to use to run the study, and you can only see it because I made a team and I added all of you or whoever sent me their ID to this team, and I set the permission to be read. That means you can only see the study that I run. Who is this useful for? So for example, you have a customer that you want to see the study that you run, but you don't want them to run anything. You have like your manager who only needs to see this stuff. They don't need to touch. So they will be added there like that. And I also made a shared project that you can use after this workshop to run your studies for some time, right? So this project, your personal project only has 3 hours. So you will run out of hours pretty quickly. But this organization has about 2,000 hours and of simulation that you can run. And more importantly, it has access to 600 parallel CPUs. So you can run a lot of things. Your personal thing has access, I think, around 100 CPUs that you can run in parallel. So pretty quickly, that will get to the point that like it's not, like as fast as you want if you start running larger study. So now the way it is, I start getting a recipe, click the same thing here, but instead of using the demo project, I'm going to go here and I'm going to go to, what's it called? AECtech, and I think it's on the next page. Give it a second. AC. So this is AECtech 2024 demo. So I'm going to select this, and something interesting happens. There are no recipes for me to run. Why? Because even though we let you to run everything that you can quickly on a public project, your personal project, which is meant to be for testing, when you have an organization on Pollination, you don't want people to come and just run everything. You don't want someone to come and like hundreds of UTCI studies if you don't have money for that project to run UTCI studies. So the way that it is, the owner of the project can go there in the demo project, and you can basically pick what are the recipes that that project can run. And from all the available recipes in the on pollination, right? And this is the place that I can, for example, say, we can run the daylight factor recipe. And it takes a little bit to load, but then something interesting happens is, unlike Ladybug Tools recipes, pollination recipes actually have different tags. So I can have daylight factor 0814 Viz, and I can have daylight factor 0814. And the difference between these same versions with different tags is the outputs that they have are different. I'll talk about it in a second. So what you need to do really before running a study for like a large study, take the time and understand the recipe, understand different flavors or tags that are available, and why. Why is it important? Because if I select the Viz recipe, which was the one that we selected by default, it will generate a visualization when the simulation is done, which is great if you want to share the thing on the clouds people want to go and see. But if you want to load the results locally and do some post-processing, then this is an extra step that you're doing and you're not going to use. So in that case, I'm going to use the 0814 without the V stack. So it just removes that extra step for generating visualization. Does it make sense? For annual daylight, for example, some of the other ones you go, they have 3 different tags. And you have to study these tags before running them. So for now, I'm going to just to select the one with these because that's better. You can see the things online. And then I click on add. And now the recipe is added to this project. So I can close this. You can see the recipes here. You know, I can run it if I want from the cloud, but I don't want to do that right now. I'm going to go back here. I'm going to get the recipe. And I'm going to go to the here, second one. And this UI is not great. I'm the first to say, like, we will improve it. So now if I go to the demo project, I just add it, I get, and you can see I get a specific version of the recipe. This is another thing. I could have selected the star, which basically gives you always the latest, or you can freeze the version of the recipe so you make sure people just run the exact version of the recipe that you want. So now I can connect the model here, right? And I can connect this here. So I fixed the first thing, which was use the recipe from the correct project. So now this thing is running under extended trial project and organization and under AECtech 2024 demo. The other thing is, for every study that I run, I need to also send the input data that I have. And that's where this user data comes in. So if you remember, so far we have used user data to collect all the outputs. Now we can use the same component to use the inputs. So what I'm going to do, I'm going to go to use this user data. And this is where the magic happens. Before this, what you had to do, you had to connect them one by one. Basically, you had to do this window to var ratio, right? And then right click here and say this is an input, and then go here and connect this from here to here, right? And then you had to go the second one and the third one, and that was a lot of work. So what you can do now, and we simplified this with Fly, if you connect Fly ID, this component should be smart enough to understand it. And now I get something. I said one of the names has what it doesn't like, so I have to do like this. I have to do like, this is a limitation. I have to talk to Mingba. I don't know why we put it there. It's not my favorite, but now you can see it gives me all the data for my input, right? So now when I submit the study, I know these are the input values that was submitted with this study. So this goes here. That's one. The other thing is I said I want to name every model based on the input parameters too. So how do you do that? When you create the model here, there is a name input. You always make sure that, again, you use the ID and name it based on that ID that you have. Does it make sense so far? Okay. So we are ready to go. Should I go? I like, she's like, no. Well, why not?
Test it.
What?
Test it.
Test it. So should I test it? Okay, let's test it. Second run. So one thing, and I just saw we only have 15 minutes, so I have to give it away. So one thing that you should know before submitting is how do you want this study to use the resources? If you remember, I showed you like we have how many 600 CPUs that you can use under this organization when I run the study. But then now you see here, there are other inputs here. There is a CPU count input on the component itself. And by default, it's set to 50. What does that mean? That means that you're telling Pollination that try to distribute this simulation to 50 available computers, if they are available, right? Do I need this to go to 50 computer? It's a single freaking room, right? You don't want it to go to 50 computer because when you distribute a simulation, there is an overhead. So you don't want it to be too small. Because of that, we have another check here because we know people don't check this. They just go, even with a single room. We have another check here, which is called minimum sensor count. So what it does, it basically says, okay, I'm going to try to distribute it between 50 different computers, but I check and I do that as long as every sensor grid has more than 200 sensors. So that's the minimum value that you put there to check. If you put this to 1, then it will go and just like break it down to as many as you want. And if you run one simulation per sensor, it's not going to be faster because every time that you start a new simulation, it just starts adding some overhead, right? A new machine should start. So this is something that you have to play with to get a better sense of what is the right number for my study. Because there are 3 parameters here. One is how many total CPUs do you have? You have total of 600, right? And in this case, if I want to run everything, I'm going to run 36 simulations. So that means I want every simulation to kind of use 600 divided by 36. Does it make sense here? So I don't want one simulation to take 100 CPUs and block everything else. So that's why for that, I have to play between these values and make sure what I'm doing is right. So that's one of the other things that you want to check. When you run a test study, and why I cannot turn this off. Okay. When I run my next test, what I'm going to do, I close, fly, yes, no. I'm going to do a test run again. So this is going to collect 3 of them, maybe 4, but it should give me an error because 2 of them are the same. So I'm going to run this. Yes, it didn't. Interesting. So there are 4 unique. I don't know why I couldn't. I should have been able to clean up everything. But in any case, let me go back here to pollination. The simulation is submitted here, and you see now it has 4. It has a good name. Good things are going to happen. Because I put those values in, now we see what are the values that came in, right? This is my shade count, shade depth, and window to bar ratio. That's one thing I'm going to check. The other thing I'm going to check I'm going to wait for this simulation to be done. A little bit, or I could have actually used the one that I ran before in my project. Let's see. 10 out of 16. So this is 19 instead. Let's let it finish. On my, let me go here to my project under demo while we're waiting. So one of the other things I'm going to check is I'm going to check one of the runs that I had, and I'm going to go to this debug place. And I'm going to start looking at this, and I see, okay, based on the number of sensors that I had, it actually broke it down into 4 CPUs to run. So maximum, this is going to use 4 CPUs. So I have 36 that I want to run. I assume no one else will run at the same time, or you can't because I blocked you. So that will be, 36 multiplied 4. So it's like, 120 plus 24, 144. Okay, I'm good. I have 600 sensors. So that's a good number. But I'm going to do this math. Do this math before submitting your stuff. Then the other thing is now these things are done. I'm going now down here. And this time, I'm going to select this thing that I ran, the new one, right? The second test run. Oh, it's not correct because I have to go and select this project. So it's called extended trial. And again, I like text and copy pasting, but you can double click here on this and go through the UI if you want to select a project through the UI. I just feel like that takes a lot of time. So it's called here. This. Now that I did it like this, I have a good news for you. When I get my output here, I can also get my inputs. And part of the inputs are all the user data that I put in. So the window to our ratio, shade depth, and shade count, they're all here. That means when I'm running my fly component down here, I can, let me remove this stuff. So this stuff's being read. So now I can actually take this and say shade count is 1, and I can go here and change this to be an input, not an output, remember? Then I can do shade depth, and I can do, this is, I think, because of this image is empty, this is why it doesn't do the automatically adding things. And this one. So now input, input, and all that. So now if I basically click on fly here and fly this thing, this will go through all the 3 of them that I have. And it not only collects the outputs that I have, it also collects the input. You think I'm doing it and this is right, but look at this. Didn't work. Why it didn't work? Because one thing that we do in pollination, which is useful when you submit stuff and you want to work, we make this component non-blocking. That means they do not wait for the things to be downloaded. They just pass the data down. And because of that, it didn't wait for the slider to be done to load the result and all that. So before loading the result back, make sure you just right click on all the components which have this sign here that are non-blocking and make them blocking components. So that means now if I click on fly, it should actually work. It didn't. What is it? Study, let me click here. That was not, oh, wait a second. Why do I have two of them?
I'm sorry, I ran one of the projects.
Thank you, Chris. That's actually
so-
something that I wanted to show. So, okay. No,
That's
because
my
you are
fault.
an admin.
Mhm. Sorry,
but-
yeah.
No, it's okay. But why this thing? Okay, this was not part of the thing. Invalid pollination run input. Because it doesn't load the run for some reason. Not the ending that I was looking for. I have no idea. I never had this issue. Okay, I don't know what was wrong with that, but it needed a Control E to make things work. And now I can fly it again. And we have 5 minutes. But now I got the result that I wanted. You see, I basically got everything. The only thing is I have run index here, and probably I don't want run index. You can go and delete it in the CSV file, but you can also do this nice thing. You can right click on the input here, and you can say exclude from recording. So now if I run this again, this will do it. This will give me that, but that one is excluded. And this time it ran pretty fast. That's because this component checks when it downloads. It checks, and if the thing is cached, it basically doesn't download it again. It uses the cached data. One good thing that's happening here is I could have run this from a different computer, right? I could have totally run this from a different computer, from a different file, because the whole logic of loading the result from cloud is now separated from submitting the simulation to the cloud. And I'm going to do the thing that we have been waiting for, full run. Okay, I'm going to remove this. And I'm going to let it fly. Any questions? No questions? Or are you just so tired after 6 hours of workshop? And this is telling me they're duplicate ones. Remove it. Thank you. I have 36 of them. 36 of them. Let's run it. Yes. So as simple as that, 36 of them. You can still use your computer, and it should be already submitted to Pollination. So if you go to AECtech demo, there should be another one that runs 36. And you can see this is the study that Chris ran under the same project. And that's something important that I wanted to mention was one of the things. So, and I'm going to go over, I'm sorry, for a few minutes. One is when I uploaded the files, everything gets uploaded here to the root folder of the project. And Chris did the same thing. So we're technically overwriting each other's files. And because in this case, the rooms are the same, it's not a problem, but otherwise it would have been a problem. And that's something that you will do the same thing here probably because this project is shared between all of you to test your stuff. So to protect yourself, there is a subfolder here, when you submit your studies, pick a unique subfolder. So when your files are uploaded to Pollination to run the study, everything goes under that subfolder. Otherwise, there is a chance that other people overwrite the stuff that you write. Other than that, we let the simulation run, and I'm going to go through my slides unless you have any questions. Anyone has any questions? No?
Mostapha, do you have documentation that talks about
Yes.
what is the logic behind the non-blocking and the other things that are hidden in the fly component?
We have, yes, that one I have
Okay.
a video that for the non-blocking, no, that's some video that I have to record, but you can see it on the forum. That's a very common mistake. For the
Okay.
other ones, yes, there is a YouTube video that was on top of the Design Explorer app. So which I also, so app gallery, Design Explorer, go to app. There is a video that I go through the whole like things that we did, this one.
Okay.
That basically covers most of that, this thing.
Okay. Perfect. Thank you.
Right, yeah, you can go through those. It walks you through that. So, and there will be more video. Again, as I said, the goal of this workshop for me is like you to be aware of all the things that can go wrong. I know that there will be video tutorial, there are things, and you can figure out, and there are sample files. So one thing is not all the recipes scale the same, right? That's why when I ran the daylight thing, I went there and I checked like how many basically CPUs one single run is going to use to make sure I'm doing it right. If you start running energy simulation, you'll be surprised. Your model is small, your model is large, it still uses one CPU to run the study. So make sure the honeybee energy simulation, at least that's the recipe. That means get to know your recipe. I know it feels weird, but you need to get to know your recipe. Just run some small runs, check the inputs, check the outputs before doing larger study. I can't tell you how many people have run like hundreds of simulations and then they come to us and they're like, oh, why I don't see the full folder? Because you didn't check and you selected the wrong tag. Select the right tag to match. And there are people who, for example, you select the full study that generates everything and you never use that folder. Don't do that because all the things that you do actually will add to the time that you run. You don't have access to infinite resources. No one else does. There is this thing that people think, oh, cloud computing, you have access to infinite resources. You don't. You really have access to what you pay for, right? If you have different tiers, if you have on free, you have access to less resources. You know, if you pay more, you have access to more. But just make sure you understand the resources that you have and then set the number of CPUs, minimum sensor counts carefully so you don't end up with a way that like you have one simulation taking over all the resources. There is a difference when you want to run one large simulation versus you want to run hundreds of a smaller simulation, right? Make sure you take care of that. Then total available CPUs are different from CPUs per recipe or per broad. Total available is what is available to the whole account. The CPU count that you see on the recipe are the number of CPUs that you want to use for that run of that recipe. In this example, we had 600 for the whole account. I said you can use up to 50 CPUs when you run this daylight simulation. Then for cloud simulation, always use a subfolder when you submit your stuff so other people don't overwrite your files, you don't overwrite other people's files. Then for cloud simulation, every single additional output that you have, it adds an additional zip time. So this is how it looks like. What we show you on pollination end is like this. What really happens in the backend is this. So every output gets zipped before you can download it. Why is it important? Because if you run a large annual daylight study, and if you select the full one, it will try to zip the whole result folder. If you don't use it, then pick the one without the full, pick the one with Viz, or pick the one that is Express, I forgot what it calls. So be careful about the recipe that you pick and number of outputs because it can just add a lot of time to the study without you using them. Then be aware of all the, oh, I didn't talk about this one. So one of the other things that happens is when you connect this to this, as you saw, the recipe really takes a file as an input, right? But here you connect a Python object. So every recipe has something, or most of them, they have something we call handler or alias. What they do under the hood, they take this model and then they translate it to what the recipe wants. It's usually like write them to a file. For this small model, it's fine. But when you deal with larger models, it can take a long time. When you connect every input, it will try to go and save that model again and again and again. For that not to happen, what you should do is use these components to save the file to HBJSON or HB pickle. Basically, save the file locally and then connect the file here. So it will look like this, right? And then you dump it and you connect it. This is helpful because then it means like when you change other parameters, this component doesn't try to go over and over and over and calculate those things. And I'll be done soon. Is don't forget to create a unique name. Otherwise, you overwrite the files. This is important. The way you can set the unique name, use the ID connected to the name, and that will be do that. Don't forget about the non-blocking components when you're downloading the results. Otherwise, it will not wait to download. That's the ones, right? Look for this thing. That's non-blocking. And one thing that we didn't cover is Kubernetes will kill your pod. When you run large studies, and this is a HICO, it says, I will kill your pod for any reason. And that's the technology that we use to run all these things in cloud. You just kill it. Like it just, I'm sorry, I'm who I am, all the best. You can read the whole thing on this link. We try our best to basically check what's failing, retry. But sometimes when you have larger studies, this is like 700 things that you run, things will fail. There is an option to retry failed runs. Don't go ahead and try to rerun everything, right? Just go use this and retry failure. And this is very common. Again, as pollination gets better, we do better. Like there will be fewer that fail, but basically there might be a data center get on fire. And I'm not joking, like that really happens. And when that happens, your run basically fails at that point. We try to resubmit it, but after 3 times or 5 times we try, then we cannot resubmit again. That's your thing not to run it again. You can also use the API if you know Python and you run large studies. There is documentation there how to do it, so you don't have to use Grasshopper. At some point, Grasshopper gets really slow for larger studies. And the upcoming feature are better post-processing for custom post-processing and better queuing. And I'm sorry I went 7 minutes over, but I would like to take the time if you can stay around and tell me what's your wish. What are the things that you think can be improved? And if you have any questions. And let's see if the simulation is actually done. So 36, and that's the thing, like, so 36 took around 3 minutes total to run, right? Around 4 minutes versus, I don't know, 4. How long does it take for 4? Like 1 minute. So you can see how the thing scales up, right? And this thing, if I wanted to run it like one at a time, would have taken 1 hour, 32 minutes. This would have taken only 4 minutes. So this is where the scaling happens. So you go from 4 to 36, and the difference is just like, 1 minute. Then you get larger, go 36 to 72. But again, remember, this one has 600 CPUs. That's why nothing blocked each other. So they could all run in parallel. Any questions?
So in general, the inputs for the fly should be sliders. Like, for example, if I want to test different materials, that would want to.
Yeah, so if you want to test different materials, let's say, if you use the materials by name, you can basically create a list. And then, have material 1, material 2, whatever you have. So you can have a list of materials 2, and then you can list this. You can either use a slider or you can connect this directly to Fly ID. Does it make sense?
Yeah.
Anything that you can iterate through, you can connect it to the input.
Thank you.
Yeah, no problem. Any other questions? Sorry that I didn't get to push that large model in the mix because that was not part of the plan. But for large model, the thing that you should just keep in mind is this: set the CPU count correctly based on the total number of sensors that you have. And if you're running it parametrically so many times, make sure you save the file locally and you upload like a smaller file instead of just connecting this to this. So that's basically are the main things that you have to keep in mind. If you end up running thousands of simulation, like very large studies, then get in touch. I help you with the process. But either you have to use the API, or if you want to use the Grasshopper UI, you have to break down the process. You have to upload everything, upload all the files first, and then use this component to reference. Component tries to upload everything and then a schedule running them, this one, which for very large studies with large model, let's say you have an urban model that you want urban study, and you want to run like 100 different iterations of that or thousands of that, that can take a long time even to upload. So you have to break down the process. You have to be a little bit smarter to how to submit them. But again, that's something that you can always get in touch with us and we can help you through the process. Any other questions? Should I stop sharing? Did it make sense overall? I hope the Fly component, at least, like you get a sense of, it's very generic, it's very dumb. I will share the slides with you, so read that like twice a day when you want to do larger studies, so you don't make the mistakes. But again, like we all make mistakes. That's why you have to do the test fly before, right? To make sure like you catch your mistakes before running things. And then make sure, I think that's something our UI should be better, but make sure you pick the correct recipe for your office projects or run it locally. Don't submit your confidential projects to cloud under your public projects. If you do, you can always delete them, just so you know. It's like, you can always go and just delete them there, but be careful. Okay. If there are no other questions, then I think we can wrap this up. Thank you so much for attending the workshop. The recording will be available. We, like the TT Core Studio team, will do the editing and everything, and they upload it on their YouTube channel. I believe they will send an email. If they didn't, we will also send an email. Meanwhile, you know how to find us, how to reach out to us. You can ask your questions on Discord. You can send us email, and then we will tell you, post it on Discord. Unless there are confidential information about your projects, which we understand, we will help you with that. Thank you so much, and I can stop recording, and then we can talk about questions that people usually ask after I stop recording.